the solar system does not behave that way at all. In fact, the solar system it behaves in a completely different way, since the sun is moving through space and the planets are flying around the sun, generating these huge vortices as it follows the equator of the sun. That is a completely different picture. All right? It goes from flat to spacious, to movement through space. And that makes a big difference. All of a sudden, you start to see that even planetary motions, solar motions around the galaxy, galactic motions, supercluster motions, and so on, all have this elliptical, vorticular dynamics of space. They all have this torque dynamic through space. And if you look at the Earth on this vortex, you could say that this is 2000, 2000 for instance, and this would be then 2001, and then this would be 2002, and this would be, this is extremely long distance apart. Millions and millions and millions and millions of miles apart. There's nothing in there, the planets do not come back onto their path. They don't. If they did, we most likely would have the same set of information over and over and over, like a broken record. Okay? And we'd probably get real bored. It would be like Groundhog Year, And so, what makes, and so it hit me in my head, oh my God, what makes every second, every billionth of a second different from the other, every part of the division of space-time different from the other, and why is information changing, is because we are never moving back onto the same coordinates of space-time. We're moving through space-time, gathering information through the system and feeding it back and modifying the structure of space as we move through it. So it was really an important realization. It had implication in the physics I was writing, but as well it had implications in psychology theories and stuff that I was interested in, because you could, I've experienced and experimented on this since then, where if I give this visualization to somebody and I ask them in their mind's eye to move the Earth back along that vortex to an instance, to something that happened in their life that was traumatic, I'm able to get these people to go back to that moment in much more vivid and much more powerful way. And then what I ask them to do is to change their visualization of that experience from their perspective to the 180-degree perspective, like to the perspective of the person that assaulted them or whatever. And then they get a new set of information. And what I believe happens is that new set of information is encoded in that place in space-time. And so all of the rest of the information is changed from there on. And that is actually the effect of psychology, asking you to go back to an instance. But if you don't know, and I think that's where psychology could get some help from this theory, is that if you don't know the true dynamics, the fundamental mechanics of that motion through space, you're going to try to visualize it in something that's going back in time on the same record, broken record, so you can't get there, right? But here, I've had instances where people were able to do that and solve some very, very important issues immediately. And what happens is that if they're there in present time, then all the geometry that catch up with them now opens a whole new sets of geometry for them in the future. So that was really exciting. So I was on this bank of the lake, and I'm thinking, wow, you know, I've got something here. I gotta think about. I want to do an experiment, to do something to be able to, you know, show this. Am I correct? You know, and I thought, how could I experiment to show a 3D kind of 3D wave instead of a flat wave? And I thought, okay, well, if I have a spinning motor that would give me the torque of space-time, and I attached a string to it, maybe I could, let's see what it does, you know? So I went back to my van, and I'm looking for an electrical motor. I couldn't use the V8 engine of my car. I was looking around, so I finally found one in the razor that I was using. It was an electrical razor, so I took the head out of the razor and I dislodged the motor, and then my razor was stuck in my experiment for a long time, so I grew a beard. I did. Here's me with a beard. And so, because I had no razor, and so my rope, I took a little fishing rope, and I took a little bit of a weight, you know, fishing weight that had a swivel on it, and I attached it to it, and I turned the razor on. And the result was so exciting. I was amazed at the result, because as soon as I turned it on, it went into coherent waveforms. And I used to go around physics talks with my little razor and my little string, going around showing people about a 3D waveform, and it was kind of funny. I'm going to demonstrate to you what happens when you spin and when angular momentum is applied to a string. And this is what happened here. So if I can have lights down, let me try to get this going. Okay. So here we are. And so we've got little motors that are going to spin this. And here's the coherent waveform. And here, with the strobe, I can stop the waveform that's actually a 3D wave. And can everybody see that this becomes a 2D sine waves? And that's how we visualize it. But actually, if I show you the whole thing, then you see that it's actually a 3D vortex, right? Spinning in space. So let me show you again. I gotta change the strobe frequency. There we go. And can you see how it becomes? It seems to be a sine wave, but actually is a result of a vorticular action of a rotating system. Here's a nice stable interference waveform. And interestingly, when you look at the central part of these waveforms, you can see structures that look like Mandelbrot fractal structures. And you can get much more complex one. Oh, this is a simpler one. This is a 2-wave. There's a 3-wave. I like that one particularly. There we go. Here's the sine wave in strobe stop. Can everybody see that? And then you can get, like I said, very complex interference pattern that you would expect from wave dynamics. This is a stable one. There we go. Here's a pulse. Here's highly complex waveform. So, lights up. This is my string theory. And it's a toy, but I think that it's a toy that actually has a lot of significance in the way things work and how physics function. You know, just like a string from string theory implies a lot of complexity in string theory, but it's only a string. Well, in here,